So again, today we're going to talk about transform plate boundaries. Take some notes on that, and you need to study divergent and convergent boundaries for your quiz that you are going to have on tomorrow. So first off, we're talking about transform plate boundaries. The screen is going to be a little bit split because I'm going to be taking notes on the left side of the screen that you're looking at, and there's going to be some pictures that are displayed on the right side of the screen. Until my technology gets all the way set up, I gotta make do. So let's go ahead and right now, you'll be able to see my writing. Let's go ahead and put our title on here. Transform, this should be transform plate boundaries. I'll zoom in. Everyone can see that, right? And there's not a lot of notes to take for this because transform plate boundaries, are boundaries that do what? Okay. They don't slide. They don't transform. They do what, Tim? They slide past each other. So that's what we're going to be taking notes on. So let's look at this particular picture here that we're seeing on the right side. Yesterday we noticed and the day before yesterday we noticed from our assignment that we had to do with world maps, what did the transform symbol look like? Can't hear you.
It's like two arrows on top of each other.
Two arrows on top of each other that go opposite directions. What is that telling us?
It's like they pull it.
They're not pulling apart. They're not pulling apart like this, where my two hands are separating apart from each other, or my two fingers are separating apart from each other. They're doing what? One is going this way and the other one's going that way. So they're not pulling apart like this. They're actually sliding past. So they're shifting. Good. They're still kind of together, but there's a shift. So if we look here, we notice this is what it's saying. So let's just draw just a little picture here. First of all, let's say what a transform boundary is. This is when the plates do what? And I like the word that Tavarsia used. Shift, and we'll just put in parentheses, past each other. So if I was drawing a continent, and obviously this is not a real continent, but if it were, we'll label it continent 1 and continent 2, because that's what I would name my continents if I created continents, because it would just be easier to identify them, right? And one goes this way, and the other one shifts this way. So it's a shift. Does that make sense? Fair enough, right? Any questions? All right. Now, that shift is for instance, if you had a piece of paper and once you have something, give me one moment because I do want to give you all a supply. Was 2 plates, right? These plates are going to represent what? One continent, 2 different continents. So I want you to go ahead and place your plates together. Because at one point we are saying that the continents used to be together, and then something happened. All right, go ahead and put your tape to where your 2 continents are together. Nope, just put it right across because we're putting them together so that they stay together. So at one point, we're saying that the continents used to be together. So far, we learned that the reason why our continents look the way they should look is one of the three things happened. What was one of the things that we learned thus far?
They converge.
They converged, meaning they collided together, and that's how we got certain. That's how we got certain what? Features like volcanoes, mountain chains, things of that nature.
Like they're like unknown sinkholes.
Not if they converged. And then we also learned that the continents did what? They diverged, meaning they pulled apart, and that's how we got what?
Africa.
Trenches. Well, trenches would have been from the convergence because they did together. Hold on. What else did we get?
Mountains.
Like,
Coming apart on the sides, yes. What else? Okay, earthquakes, volcanoes. There's something else that's called a Midocean Ridges. And then now we're learning about this transform, and transform means they did what? They slide past each other. So what we're going to do is you're going to take your two plates and you are going to shift them kind of with a lot of force because these are continents. These cannot shift just slowly. It does happen with some force, but it doesn't happen all of the time. But when it does happen, it is something that is noticeable. So take your hands, put them down flat, and then what I want you to do is shift them. And what's supposed to happen? What happened?
The tape rip.
Your tape did rip. And when it ripped, some of you are weak. This tape is strong. I am. All right. If it were to work, because we're supposed to have tape underneath to kind of make them not slide, but notice that when it did shift, your tape did what? What's another word for that? Broke. So your tape broke. So what's a word that we learned last year on a event or a feature? Nope, a feature when something breaks. Like, ooh, you broke it, it's your fault. So a transform plate boundary creates faults. And faults are what again? Nope. They're breaks. Breaks in the plates. Bars.
I'm gonna let you get off your video.
Don't worry about what the players do. All right, so transform plate boundaries creates faults, which are breaks in the plates. What event does this cause? Or what does this result in? Nuh-uh. Earthquakes. Right now, if our continent, where we live right now, were to break, notice that it took some force for you to push those two continents against each other. That force and that movement of the continent is a earthquake. There was. It was like 3 years ago. Yeah, the school I worked at, we kind of felt something. We had no idea what it was. And in my neighborhood, later on, we got home and noticed some pictures were on the floor, and we're like, oh. And we had no idea what happened. Like, we felt something in school, but we thought maybe, we don't know what happened. It was like a little tremble or trains or whatever. Hold on, so guys, come in the middle talking. And then when I got home, I noticed some pictures on the floor, and then we watched the news. We're like, oh, we had a minor earthquake. We didn't even realize it. All right. So there are some famous faults that have happened in our world that are just ones that are noticeable and things in our history. One of them is the San Andreas fault.
Oh, I seen that movie. Isn't that supposed to break the
Yeah.
I seen that
I'll
movie.
just put a,
I wouldn't see it now. Can we watch
no, we're getting off task. So I'm waiting for you to get back on task. So the San Andreas Fault is one of the famous faults that happen, and basically all that is because the continents have shifted. So this just lets us know that this is still happening in our world. It's not something that we just say, oh, our continents have shifted years ago. That's why we have our continents the way they are now. We're still moving continents. Not we're, but our continents are still having some movement and some things are still happening. So that's one thing that you might want to just make a point of. It's still occurring. All right, what's happening in this picture? Raise your hand and tell me something. Not that one. Raise your hand and tell me some things that's happening in this picture. Miracle.
Like,
And be specific, like name out the area that you're looking at because the continents are labeled.
well, I'm looking at the Pacific plate, the South American, well, basically all the plates.
Well, just talk about one area.
Okay, well, the Pacific plate and the, what's that with the end? I can't see.
Nazca.
Yeah, the Nazca plate, they like, breaking apart,
They moved apart, so what type of boundary is that?
diverging.
Divergent boundary, okay. What else do you see in this picture, Michaela?
The North American plate and the Eurasian plate, right? Yeah, and that one, they're breaking apart.
Which is a
Divergent.
divergent boundary, okay. What else do you all see?
Oh, South America and Africa.
South American plate and the African plate,
And,
divergent boundary. What about the Indo-Australian plate? And this is part of the Pacific plate because, as you know, our world is round. What do?
They collide.
They collide, which is a convergent. And even though these two shifted the same direction, we can kind of look at that as a transform because they still pushed, it still was a movement there. We're going to be looking at that information. What are these black lines representing?
the plate, right? The outline.
They are boundaries, but what is this showing us? So,
Where they could go.
outline of what?
The divergence of the plates.
But if we look at this, could we say that at one point there wasn't water here?
No.
This could have been all Greenland,
Yeah.
all Greenland. Because remember, at one point we're saying that we used to have one big landmass, which was called Pangea. And the reason why we have this water is because of the break. They moved apart from each other. Yeah, we had Midocean ridges and things of that nature, but they moved apart from each other. So I want you to recognize that when you're seeing it. All right. Excuse me. All right, there are some reasons for plate movement, so we want to write on our notes here. Now, when we look at this picture, this bigger. When we look at this picture here, as soon as I can make it bigger, we notice that this is the Earth. We have the inner core, we have the outer core, we have the mantle, which consists of the asthenosphere, the lithosphere, and then we have the crust on top. We notice there are a couple things that are going on. There are movement, if we see these red arrows, this movement going around. This is the movement of the lava that's within this sphere that's moving around. And we learned in our weather unit that when like the air moves, this is called something, starts with a C. It's a type of current. Convection current. So one of the reasons why the plates move is because we have convection. Oh, sorry. There's also, if we look here, a ridge would be like bumpy area. So usually that movement it causes our plates to move also. So another reason why we have plate movement is because of ridge pull or push. The ridges are pushed. And then these plates can also be called slabs. Like you've heard of like a slab of meat. That's like a piece of something. So we also have something that's called slab pull. That means that the earth is pulled apart, the ridges are pushed together, and there's convection, there's movement of lava. So once that lava gets so hot, it's going to try to get out. There's a lot of pressure there. So we're going to break these three things down, and then this is going to be ending of our notes. So we're going to look at these three type of reasons, and we can call these convection currents. Can I move?
No.
All right. I actually want, we're going to draw this and then we're going to label it at the very, well, let's draw it first. I'm going to make this part bigger. Not yet. So just in drawing our earth, and I'm drawing it like this for a reason. But down here we have our we have our inner core. That's not to size, that's just to give you a general picture of it. We have our outer core. Yeah, I need you to draw this. This is considered our mantle. And this portion is our asthenosphere. And within our mantle, yeah, we have this going on. If you want to use colored pencils, there are some at your station. And everything I do, I'm going to do in a separate color. And then I'm going to underline what they are. So here we have, what are these? What are these red lines representing? What's reason for plate movement is it representing? Out of the three reasons, what's the red circles? Convection current. So the movement of the lava within the mantle is the convection current. Then when this lava is moving around, it's going to open up, and when it opens up, it's going to create this little thing, which is called a ridge, because it's going to open up and push that stuff together so that you're going to have a little ridge there. So this is your ridge push. This right here is considered your lithosphere, because the thinner part of the mantle. Now, this deep depression in the earth is considered a what? When there's a depression or a cut in the earth, what is that? What feature is it when the earth has a cut in it or a break in it, where a trench? This is a trench. This cut is a trench. And if you notice that part of the earth is being pulled in, it's cut in, so it's being pulled in because the two plates come together, so one part is being pulled under the other. Obviously, what would that be? Out of the three reasons, this is a slap pull. The earth is being pulled under. Any questions for that? Can I move from here? And now again, we're just going to break down the three. I'm good to move? Yeah. All right. You can go over to the back if you need to. I'm just going to take on another piece of paper just so that I can have mine together. 54. All right, so just looking at the three of them. Convection current, going into more detail for it. Again, this is a reason for plate movement, which we already had on the front. Now what's happening here is the hotter parts of the mantle rise while cooler parts do what? If one part's going up, the other part's going, which is called what? Starts with an S. Sink. That's what a current is, just like our air currents that we learned about. And this puts a force on the lithosphere. And that force, tell me what a force is. A what or a what? Or a pull. So there, if someone pushes you or pulls you, you're going to do what? You're going to stay stationary, or you're going to cause movement. So this puts a force on the lithospheres, causing plate movement. This is why plates move. So right now, we are just breaking down those three reasons for plate movement. Understanding that convection current does this, this is why the plates move. We're almost done, 1 second. The other one is ridge push, which I identified in black, but you could have used any color that you wanted. And I just wanted to show you the picture really quickly for a ridge push. Come on. right, looking at this, what's going on with my computer? Looking at this picture here, and I'll make it larger in just a second. We'll notice within this, okay. We'll notice with when we look at this picture that you'll notice that the Midocean Ridge, its new oceanic crust is created by magma rising. So when we look, you notice that these plates are being pushed apart, and you have a mid-ocean ridge that's being created because of the lava that's rising above. That's what's going to create that mid-ocean ridge. Do we see that? Because these two plates are being pushed apart. So if you see this picture and you're asked what's happening here, you are going to say what's being created. What's happening in this picture?
The magma is rising and they
Creating a new.
Never mind.
What's being created? The words are on this one. If I say what's happening here, what are you going to tell me is happening? The words are there. A mid-ocean ridge is being created because the two plates are doing what? Divergent, and meaning they're being pushed apart. All right. So back to our note portion. All right. So along new oceanic crust is created as magma rises from the mantle. If that magma is rising from the mantle, in order for it to get out of the lithosphere or out of the crust, in order for it to get out of there, what must happen to those plates? They got to move. They got to get out of the way. So pushing the plates apart. Think about your skin. If blood is coming out, it's going to open up your skin, pushing your skin apart. That's why it's open, and then a scab has to form to stop it from doing that. So just think about that when you're thinking about the earth and what's going on with the earth. Our last one was a slab pull. Which I identified in green, and again, you can do it whatever color you did. I'll leave this up here for a second, but I do want to show you a picture just so that we can see it. Can I move? All right, I'll wait a second. It'll come back. 1 second. All righty. Come on. All right, so here's this. There, nope. You're slow. My apologies. Here's a slab pull. So we notice that a slab pull happens because the two plates are going to collide, which is what type of boundary? Convergent boundary. But it is a breaking in the crust, but they do converge together, coming together, and one of the crust is going to do what? Start shifting its
Going underneath the other.
It's going underneath the other one. In order for one to sink underneath the other, it has to be more dense or less dense. It has to be more dense in order for it to go under the other, else they would kind of be along the same lines. So when we look at that, it's because one is being pulled under the other, and the reason why it's being pulled under the other is because it's more dense. So let's go ahead and take our last portion of our note here. What zone is this happening at? Good. At the subduction zone. The denser, what plate is denser, oceanic or continental? Oceanic, very good. The denser oceanic plate does what? Yep, it's being pulled. So let's use that same word so that you can link it together. Is being pulled down. Any questions about that? All right, then that does end the notes for this section. You are going to need to study for all of your plates.